Hello everyone, it has been quite a long time since I posted a new video, but in this video I'm going to show you how to convert this normal hardtail mountain bike into an e-bike. This is my little brother's bike, and a few weeks ago he talked to me about turning it into an electric bike, and we took the steps and ordered a kit from Ciclotech in Spain. And I will show you what we got just a few days ago. This is what arrived in the mail. My brother wanted the motor in the rear wheel because his suspension fork in the front is in a really bad shape. So we thought it would be nice to try what a rear wheel mounted hub motor feels like. I don't have any experience with that yet. So that's there. It's a 250 watt, and once again that's the nominal wattage. This will do 350 watts continuous up to 600 watts, I believe, with the controller we chose. So we took the more effective one. This is a 17 amp rated controller, and here we got the pass sensor for the pedal assist. We left out the throttle and also the brake levers we didn't need because my brother has hydraulic brakes, so they wouldn't fit anyways. So this is the LCD screen with this these buttons you control the motor and the whole system with. So in this video I'm going to walk you through how to hopefully successfully install all this and turn this pretty basic mountain bike into an electric bike. Let's move on. So you can see that I have removed the stock rear wheel already, and I also took the chain away to create as much space as possible here to make it easy to mount the new rear wheel. I already checked the dimensions. The slots here in the dropouts are 9.6 or 7 millimeters, whereas the axle here on the rear hub is almost 10 millimeters. So there's a few tenths of millimeters difference there, which means I will probably have to use a file and just carefully make these slots just ever so slightly larger to make the rear hub slide in nicely. Also, the rear hub is just a little bit wider than the frame here. This is a normal rear hub spacing, sort of the old-fashioned 135 millimeters, whereas I haven't been able to measure it really exact, but based on what it looks like, the spacing here on the rear hub is probably 137 or 138, something like that. So what that means is that we're just going to have to stretch the frame just a little bit, and hopefully that won't matter. Okay, so here I'm done filing the dropouts, and you can see that's what I did on this side. Probably removed a few tenths of a millimeter first here, and then did some grinding up there with a round file to make the axle reach the bottom of the dropout slot, and similar on the other side, like so. So the wheel is installed in the dropouts, and it sort of looks okay, but there are a few things which might not work for you. First of all, there is hardly no space between the motor and the rear disc brake caliper if you are using 160mm discs. Going 180 will create a lot more space, so that's something to look out for. It looks like it should work now, just barely. You can see the gap there, right there. There is 1 to 2 millimeters room. One thing to look out for is how well these washers, which have it's difficult to, but there is a thick washer there which is supposed to fit in the dropout and prevent the motor from turning around, like turning with the wheel. So if you don't have room for those washers inside the dropouts, that might be a problem. Looks pretty good here on this side. There's room for the rear derailleur, and yeah, I think I will go ahead and mount the cassette now next and see if it's just a straightforward switch from the old Dior hub over to the motor hub. Let's see how that works out. So the cassette is now fitted, and it works sort of, but you can see what's going to happen here. This cannot be fitted like this against the frame. There's no room for the cassette to move. On my front wheel, there's going to be 2 washers on each side, just a normal one, and then this one, where it's very important that this part here of the washer slides inside the dropout, preventing the motor from rotating. On my front motor, these washers are mounted like so, but that makes the mounting width of this hub even bigger. I don't think there's any way to mount that way in the frame. So this is going to be interesting if we are going to get this to work. I'm thinking what I could probably get away with is to have these small washers there on both sides, and then have this washer like so, tightened into the dropout. So that's what I'm going to go for now and see how that works. So the wheel is mounted now, and I had to put one of the smaller narrower spacers there between the frame and the hub. There's a nut hidden there under positioned under those 2 first gears in the rear. On this side I didn't use any washers in between here because there really is no room, and you can see now that it's not perfectly centered anymore, the wheel. It was to begin with, but right now I think this is the way that makes most sense how to mount the rear wheel. So this is probably not something you want to do if you have a really valuable frame. Go ahead and use a rear hub motor with a cheap frame. You don't need to worry that much about damaging the frame, because the spacing here it's several millimeters wider than the stock 135mm wide hubs. So what I'm going to try to do now is to tighten the spokes here on this side to make the rim move a bit to the right. But as you can see, the spokes coming from the right side, they are already, will it focus? Not so well. There you can see there's not much much room for tightening these spokes, whereas the ones from the left, there's a bit less. They are not protruding out from the end of the nipples yet. For example, here, this is a right side spoke, and it won't focus that well. Well, you can see it now. I don't know how many turns there's left, but not many. But I'll see what I can do, and let's hope we can get the rim centered. Okay, so I'm still considering what to do with the rear hub width spacing here. As you can see, without the washer between the frame and the hub, there's not even room for the caliper adapter to fit between the frame and the disc. On the other hand, I would really like to avoid to put the spacer there, because I measured the distance here between the dropouts, and it's just 132.5 millimeters. And now when we are already up to 140, like so, I don't want to increase, to put any more stress on the frame. So what I will try to do is I will try to mill away 2 millimeters of material, which equals the depth of this washer, I think, quite closely, and see if that helps and creates space for the disc brake rotor and the caliper. So this is definitely not something anyone could do easily at home, but this is what I'm trying to do now, to see if that gives a good result. So here is what I did with the brake caliper adapter. I machined off about 2.5 millimeters, and now it fits in here without rubbing the disc. I had to add one washer on the bolts here on the outside to prevent them from touching the disc rotor when installed. But now it looks like it would position the caliper in a good position, and also puts less stress on the frame now when I don't have to stretch the dropouts anymore. So this is the way I'm going to move forward, and hopefully have everything run good now. Okay, the brake caliper is installed, and it's probably about as good as it can get now, because the brake rotor is quite a lot out of true. My brother is not caring for his bike very much. I managed to center the wheel in the dropouts, I think, as much as is possible. I've been loosening the spokes here on the left side and tightening the ones on the right to move the rim over to the right side, but now I think I'm running out of thread here on the right side spokes. But there's no rubbing, and there is enough room to both the chain stays and seat stays. And as you can see, the tires my brother is using are quite wide. These are 2.3 inches wide Schwalbe Nobby Nicks.